let's move to the energy balance.
Before going to that, is there any overall off-gas volume on this sheet?
Yes, actually it is calculated here, so we will see it just after. But you're right, since we know how much carbon, it's simple to calculate the amount of gas, of course. So, when we move to the energy balance, you have seen that here we have this is just recalling the mass balance in front of the energy balance, but it's the same. Just you see, it's just the same than what is here. Of course, you understand. I mean, this mass balance is not another calculation. It is just taking over the values from above. So, how is done the energy balance? To do the energy balance, first requires a lot of input data. And the first input data we need are these reduction heats. And the reduction heats you don't find like this in the handbooks or in the metallurgical books. You find what they call the delta H formation of the oxide of M metal oxide. And this is the heat of the reaction. M plus O gives MO or MON if you want. This is the heat of this reaction. And this you find in some handbooks. So, I would like to show you how to obtain it in the handbook. But I think you don't have some book here. Are you sure? Because of course I have my mini handbook for traveling, and okay, I can show you, but it would be better to have it in your books. And this is not very complete also. But for instance, see if I take here silicium, in this small handbook in German, it is you have silicium Se, molar mass 28, etc. You have below silicium dioxide SiO2, molar mass 60. That is what we calculated. And then if I continue, density in gram per cubic centimeter, melting temperature of, yes, and vaporization temperature, and then we have molar formation enthalpy. And here we have So kilojoule per mole. Okay. And to be easily used, I want to have this in kilowatt hour per kilo silicon. You see? What is the conversion from joule to kilowatt hour?
Times hour.
Kilojoule.
It's divided by
Hour.
it's 1 megajoule is 3.6 kilowatt hour. You agree, or we demonstrate? Is actually the fundamental value is one fundamental relation is 1 calorie is 4.18 joule. This is fundamental.
Yeah.
And so 1 kilocalorie is 4,000 or 4.18 kilojoule. And okay, then when how is it? Okay, what I know is 1 kilowatt hour is
좀 위치치는 거나?
네, 맞아. 0.277. 아,
is
아우.
1
가만히 있어.
kilowatt
아니, 일단 좀 계산하는 거 들어보자.
per hour, and it is yes, this was better, it was easier, that was not necessary. Actually 1 kilowatt hour is 1 kilowatt per hour, and 1 hour is 3,600 seconds.
킬로와트.
No. Kilowatt per kilowatt second, and that is kilojoule, because one watt is 1 joule per second. Joule second times second. The definition of 1 watt is 1 joule per second. So 1 kilowatt hour is 3.6 1 When-
one divide
0.
3006.
1 divided by. Yes. So it's like this. Yes. Because this is 1 divided.
Then
Yes.
0.27 kilowatt hour.
One megajoule equals 0.277 kilowatt.
No,
hour.
these I'm pretty sure. That must be this. But your value is for kilocal. 0.727 is due to 418.
418? 인생 고민 안 하지 오래 돼가지고 씨. 저도 그
1 joule. 1 calorie. One calorie is 4.18 joule. Sorry. One calorie. Let's do it like this. Per second is 4.18 joule per second. So, and this is 4.18 watt. And so, 1 calorie times actually you need to put the hours inside. No, this we don't need actually this. It's say
뭐
one
몰라요, 나도 좀 많이.
의미에서 이거 잡는
1 watt
두고
is
보자.
1 joule per second. And 1 watt times second is 1 joule. And 1 watt times hour is 3000 joule. And 1 kilowatt hour is 3.6 megajoule, because it is this times 1000.
Yeah. That's why megajoule means 1 divided 3.6 kilowatt hour.
Yes.
Uh,
This
Okay.
is the value you give. Excuse me.
Okay.
Didn't
Keep
get-
going.
Okay. It was a bit difficult. Okay, this is the simplest way to find it. And now, this is megajoule per mole. And so it is divided by 3.6. Can you do this? About
0.23
25?
2389 389
Yes.
0.23
And this is, and 1 mole is 60. The CO2 is 28 plus 2 times
16.
16, so it's 60. So I'm just wondering, because we are not going to find out this value, you know? but because if I want to have the kilowatt hour per kilo SE, I have so in 1 mole is including 28 kilo. Ah yes, okay. So per mole it is this, per kilo, this is for 28, per kilo you divide by 28. But actually the reason is that, I don't know why, but there is a factor 1000, and this is the real result. We have to find out, we have one.
발전은
Ah, I know. 1 mole is 28 grams, and we want to know it per kilo. So there is a factor. Agree? Okay.
너무 쉽다.
Shall I take a
A break, yes. But you know, you have understood how to proceed. Using a book, you find out the enthalpy of formation of the oxide, and you transform it like this. Okay, on the other hand, no, you have it. I mean, these will not change. They will not change over time. But if you look for a new one, it's good to have. It's good to be able to insert it, to translate it. It's always a bit headache to coming back to to basics and to different systems. To different unit systems.